In this video, we'll be looking at Chapter 11, Section F on using tree diagrams. Tree diagrams can be used to illustrate sample spaces, but they can also be used to help us calculate the probabilities of an experiment. Let's take a look at one of the previous examples that we saw in an earlier video. In this example, Sunil and Monica were both archers, and Sunil hits the target 4 out of 5 times, and Monica hits the target 5 out of 6 times. We can represent this situation on a tree diagram. Our first column will be Sunil's results, and she has two options. She can either hit the target or miss the target. Now we know that she has a probability of 4/5 of hitting the target, so we can actually write that probability right on the branch going to the option where Sunil hits. This means that she has a 1 out of 5 chance of missing the target. Now in our second column, we can look at Monica's results. And if Sunil hits, Monica could hit or miss. And these events are independent. And again, we can put the appropriate probabilities here. Monica has a 5 out of 6 chance of hitting the target and a 1 out of 6 chance of missing. And we can repeat the same probabilities for the case where Sunil misses. Now from the tree diagram, I can see that there are 4 possible outcomes by following these branches. And that is a hit and a hit by both, a hit by Sunil and a miss by Monica, a miss by Sunil and a hit by Monica, and a miss by both. These are our 4 possible outcomes. Now remember, in previous videos, we saw that the probability of 2 events really is the product of the individual probabilities. So to find the probabilities of both of the archers hitting the target, I can multiply along the probabilities along that branch. So in other words, 4/5 times 5/6. And I can work my way down the tree diagram calculating the probabilities. So for a Sunil hit and a Monica miss, I'm going to multiply 4/5 by 1/6. And all the way down. So the next will be 1/5 times 5/6, and then 1/5 times 1/6. And then we can calculate these probabilities. So we'll get 2/3 2/15, 1/6, and 1/30. So now we've calculated the probabilities of all our possible outcomes for this situation. Now, notice what happens if we get a common denominator here for all of our probabilities. So in other words, we can change the first probability, or the hit-hit probability, to 20 over 30. The next probability to 4 over 30. And then we have 5 over 30 and 1 over 30. And this should be a quick check to make sure that we've done everything correctly. If I add all of these up, or at least the numerators, I should get 30 over 30, and indeed I do, which we all know is equal to 1. Let's take a look at another example problem. We have one bag that contains 4 red jelly beans and 1 yellow jelly bean, and we'll call that bag A, and bag B contains 2 red jelly beans and 3 yellow jelly beans. If a bag is randomly selected by tossing a coin and then 1 jelly bean is removed, determine the probability that that jelly bean is yellow. First, it's sometimes helpful to draw a picture, so let's do that. From here we can draw a Venn diagram. Now remember from the problem, we're selecting a bag first by tossing a coin. So really we have a 50-50 chance of selecting the bag. Let's say so our first column in a tree diagram is going to be the selection of the bag. Then from bag A, when we're drawing one marble, we have a 4/5 chance of drawing a red and a 1/5 chance of drawing a yellow. From bag B, we have a 2/5 chance of drawing a red and a 3/5 chance of drawing a yellow. So there are only two cases here where we can meet the outcome that we're looking for, which is selecting a yellow marble. And so we want to find the probabilities along those two paths. And remember, we can multiply along those two paths. So the probability of drawing a yellow marble from bag A is 1/5 times 1/5, which equals 1/10. And the probability of drawing a yellow marble from bag B is 1/2 times 3/5, which is 3/10. So the overall probability of drawing a yellow marble is the sum of these two probabilities, which is 4/10 or 2/5.